Hi there, this short video is to look at the phenomena of refraction and refractive index using a neat little trick that can really get your kids in your lessons thinking about the phenomena in a really easy and engaging way. What you need to do this is you need a large beaker that has got I've got about a litre here of mazola oil. This is corn oil. You can see here, this is a good oil to use. Now, the joy of this type of oil is it has the same refractive index as the normal Pyrex test tubes that you find in school. So here's a normal test tube. Now, what I'm going to do is I'm going to submerge the test tube in the mazola oil. So that's why this beaker has to be large, with about a litre of oil in there, because the test tube's got to go in completely. And I want you to watch what happens when the test tube is submerged. Now remember, the refractive index of the oil is the same as the refractive index of the glass that I'm going to put in. So, test tube here, I'm going to use some tongs as it's quite oily. So there it goes. I'm just going to drop that in there, and you should be able to see at the moment that you can see the test tube through the oil. But as I dip it under and allow the test tube to fill up with oil, watch what happens. I just half fill it to start with. Can you see there? I'll do a close-up in a second of how where the oil is filling the test tube, it seems to disappear. And if I fill the test tube completely and I let go, then the test tube has disappeared. Now, explaining this can be a bit tricky because it involves some knowledge of refractive index. So there's a couple of levels you can do this at. One level is to say that we only see things when a ray of light reflects off it at a boundary and then reflects into our eyes. So for example, I see the beaker because light bounces off it and into my eye. It's a boundary. And what happens is when you make the refractive index of two materials exactly the same, is you effectively remove the boundary. So as far as light's concerned, because the refractive index of the oil and the test tube are the same, there is no boundary. The light rays just go straight through, and so we don't perceive there to be an object. Another way of explaining it, the second way, is to use the concept of refractive index and to say, okay, well, when we put something with the same refractive index next to something else with the same refractive index, the light rays, they don't deviate, they don't change speed, they don't change direction. So if they don't change speed or direction, our eyes don't perceive there to be a difference in the two materials. So we're effectively hiding our test tube in there. We call it the disappearing test tube. And I can get the test tube back out again by just searching around with my tongs. There it is, and it's appeared again. And if I empty it, you'll see there it is. And if I put it back in there, look, without any oil in, you can see the test tube, because now there's some air in the tube, and obviously the air doesn't have the same refractive index as the oil. So I hope that's useful to you in just thinking about this. It's a good demo to do. It's quite good to do using a visualizer so you can show the whole class. Obviously you do need to think about there's a bit of mess, so having another beaker that you can put it in. There are lots of variations on this demo as well that you can look online for and find other things to do, but that's kind of the basic way of doing it. Thanks for watching.